Hello everybody, today we're going to learn how to do a project. In this case, we're going to learn how to program and simulate a sequence of nets. We're going to make use of Instructive. So, let's see the steps. Step 1. Open the microcode compiler and select the Create New File option. You're going to go with your compiler. In this case, we're going to need the Microcode Studio. You open it and open a new file in this option. I already have one open. Here you're going to do all the programming. You're going to make your program and run it on your project. Or in another case, you can use it on a simulation. So, let's say the first step. Open the microcode compiler and select Create New File option. Okay. Step 2. Initialize the program with the command initio. We go to microcode and initialize with the command initio. This will initiate all the programming, so we can start to write all the commands. Also, to continue declaring our first output by assigning it a name and giving it a value of height. In this case, we're gonna give it the name of port B.0, and also we're gonna give it the value of height. I already have the code write it, but you must write it to do all the job. Next, step 3. Declare a time pause to indicate the waiting time that the command will have until the next programming line. In this case, we will assign a time of 2 seconds. We're going to microcode, and we're going to assign a pause of 2 seconds. Next step. Step 4. Declare the previous name output again, but this time assign a low value, indicate that communication with the component will be cut. We go here, and you need to write this. You're gonna put a value low in this case, and on your output you're gonna use the same name because we are using the same output. Next step, step 5. Repeat not done in the step 3 to redeclare a pause before the next programming line. We're gonna do the same thing we do in the step 3. You can copy if you want. You're gonna copy pause and the time we make. Okay, next step. Step 6. Copy and paste all the declaration and value previously assigned, changing the name of the output in descending order. Depending on the number of LEDs that will be the times this will be done. In this case, we're gonna use 8 LEDs. So we're gonna make this 8 times. We copy this and we paste. We change the output name. And repeat. We make this many times. So we can declare all the outputs. Sorry, my fail. here we got 5. So we need 3 more. And with that, we have 8. Okay, next step. Step 7. Once you reach your limit of LEDs, repeat the previous step, but this time naming the outputs in descending order until you reach the first LED. We're gonna do the same thing we did previously, but in this case, we're gonna do with a descending name. We're gonna do it with 7, 6, 5, 4, 3, 2, 1, and 0. We're not going to repeat 8 because this is the last LED. Only you need to copy this one and paste it down. Okay, we are done with this part. We continue with the next step. Finally declares the command end to indicate that we have concluded in the release of the code. So as we can see here, we are just going to declare the command end. And with this, we are finished with the program. Next step. Here we got 2 options because you can do it physically or simulating. Step 10.1. In case you have a physical project, connect your burner to the computer and then proceed to connect your microcontroller, ending with deploying your code and seeing the results. I don't have a burner, so we're going to the next step. We're going to use a simulator. Step 10.2. On the other hand, if you had a simulator, we will open our programming, and in this case, we will use Proteus 8. We're gonna open our program Proteus. So we can use our program. As you can see, this is Proteus. So we're going with the next step. Step 11. Build a circuit where the LEDs are connected to a server output of the virtual microcontroller, being able to be output A, B, C, etc. In this case, I already have a circuit. I connected a resistor to the LED, and then I connected to an output, in this case using the output C. Next step. Step 12. Double tap the digital microcontroller and select the Upload Program option. We go to Produce and double tap the microcontroller. We're going to the option Upload a program, and then step 13. Select the folder where you have the saved program and find the hex file that your computer saved and select it. We're going to our folder, select our program, and then accept. Step 40. Wait for the program to finish uploading and continue running the program. We're going to produce and start the program. We wait a little and got it. And finally, step 15, enjoy your work. And here you got it. You program and simulate a project where you're going to use a few of LEDs. And with this will be all. Thank you very much for all, and see you in the next video.